In this lesson, we want to be able to say that I can explain the properties of rational numbers. This is going to be hitting our standard, and we are going to be starting off by asking the question, what are rational numbers? We talked about this last time, but we are going to just refresh about this just a little bit. Rational numbers are those numbers that can be written as fractions. We typically say that rational numbers are an integer divided by an integer where the second one is not a 0. So remember that rational numbers are the fractions. These are any number that can be written as a ratio or a fraction of two integers. Remember, that's our symbol for integers, a z. So it's a ratio of two integers, a fraction. What does it mean for a set to be closed? For a set to be closed, we have to make sure that the operations work within that set. For instance, if we want it to be closed under addition, then we need to make sure that addition always ends up in the same set. So if we have an integer plus an integer, is that always going to give us an integer? If we have a set of, let's say, 1, 2, and 3, and we want to see if this is closed under addition, then we would have to check to see if we add any of those values, is it going to end up in the set? For example, if we did 1 plus 3, 1 plus 3 is 4, is that within the original set? No. So this set, that example right there, would be an example of a set that is not closed under addition. So that's kind of what it means to be closed. Let me just also write down this. Basically, it is a set is closed under an operation. Whenever a set is closed, whenever we basically are able to take any operation, addition, subtraction, multiplication, division, and it ends up in the same set. So that's basically what it means to be closed. It has to end up in the same set. And we're going to look at a few examples of this. Is a set of even numbers closed under the following? Okay, let's write out what even numbers are. So we have 2, we have 4, 6, 8, 10, 12, and this goes on forever in the right direction. Even numbers could also be negative. By the way, 0 is considered to be an even number. -2 is considered even. -4 considered even. -6 is considered even. And this can go on forever as well in the other direction. So our question is this closed under addition? Well, let's take two of our even numbers and add them together. So let's say we choose 2 and 6. 2 and 6 is 8. Is that within the original set? Yes, it is. So that works. Let's take -6 plus -8. -6 plus -8. 6 plus 8 is going to be 14, but negative. So that would be the result of that. Is -14 within the set? Well, if we continue the set down to the left, we would be able to see that, yes, it is. In fact, if you add any even number, positive or negative, you're going to always end up with another even number. Okay? So that is to say that it is closed under addition. So addition, I'm going to put a check beside it saying, yes, it's closed. I'll put an X if it is not closed. Okay? Subtraction. Let's say we chose 6 minus by 4. 6 minus by 4 is 2. 2 is even. That works. Let's say we did 14 minus by 12. That is also 2. That works. Let's say we did negative 6 minus by 5. 5 is not even one of our original numbers. Let's go with 4. 6 minus by 4 is negative 10. Negative 10 is even. So is the set of even numbers closed under subtraction? Well, yeah, it is. If you take any even number and subtract it together, you will always end up with another even number. Multiplication. Let's see if multiplication works. And we're just going to do a few examples. We're not going to take it to the part of explaining in depth for why exactly that is, but we are just going to be able to say, yes, we know it is. Okay, so multiplication. Let's take 2 times 4. 2 times 4 is 8. That's even. Let's take 4 and 12. 4 times 12 is 48. That is also even. Let's try some of the negative numbers. Let's say we did negative 6 times positive 6. That's negative 36. That's also even. Let's say we did 0 times 8. 0 times 8 is 0. Anything times 0 is 0. That's also even. So multiplication is also closed. Notice under each of these operations, it's staying within the set. It has to stay within the set in order for it to be closed. Division. Okay, let's take 2 of those numbers. Let's try 12 over 6. 12 divided by 6 is 2. That is even, right? So it appears that it might be closed under division. Let's try another number. Let's try 2 divided by negative 2. 2 divided by negative 2, wait, negative 1 is not even. That's outside of our set, so division is not closed. If we want to show that it's not closed, then all we have to find is just one example. There's actually a ton of examples to show that division is not closed with the set of even numbers. Let me give you another example just to be able to show you another way of showing this. Let's say that we did 10 divided by 12. 10 divided by 12 can simplify down to 5 over 6. 5 over 6 is not an even number. It's not even a whole number. It's not even an integer. It's not even a natural number. So that's another area where it would not be closed under division. So division with even numbers is not closed. But multiplication, subtraction, and addition is. Let's look at another example. Let's look at integers. Is a set of integers closed under the following? Okay, let's remind ourselves of what integers are. Remember, integers, we use this symbol here, the z. And integers are the negative numbers, so like negative 3, negative 2, negative 1. We have 0 in here. We have 1, 2, and 3. And this goes on forever as well. Okay, so it's not just the even numbers. Even numbers are part of the integer set, by the way. So let's see if it's closed under addition. If we take any of these numbers and add them together, are we going to end up with another integer? Well, to answer that shortly, yes, we will. So here's just some examples. Let's say we did 3 plus 5. They're both integers. That's equal to 8. Let's say we did 2 plus 0. That's 2. Also an integer. Let's say we did negative 3 plus 7. That equals 4. Also an integer. Okay, integers are closed under addition. Integers, interesting enough, are also closed under subtraction and multiplication. If you take any 2 integers, subtract them by each other, you will always end up with another integer. Let me give you a few examples. 3 minus by 1, 2. That works. 10 minus by 7, 3. That works. 0 minus by 4. That's negative 4. That works. These are all integers. If you take an integer and subtract it by an integer, it is an integer. If you take an integer, add an integer, you get an integer. If you take an integer and multiply it to each other, let's go 3 times negative 3. This would be negative 9. That works. We can even take it and multiply it to itself. Let's say we have 9 times 9. That's 81. That is also an integer. Okay, so you don't have to choose different values. You can choose the same value and see if it ends up in the same set. Multiplication works. Division. Division, unfortunately, does not. Just like the even numbers up here is not closed under division, division with integers is not closed as well. Let me give you a few examples. Let's say we did 1 divided by 3. That's not an integer. You have an integer on top, an integer on bottom, but 1 divided by 3 is not an integer. Let's say that we did 5 divided by 8. Right? 5 divided by 8, that 5 is integer, 8's an integer, but that's 5/8. That's not an integer value. It would end up as a decimal. So that is also not an integer. That's not in the original set. Remember, if it's closed, it lands in the original set, no matter what, with the operation. So it's not closed under division. The cool thing is, with rational numbers, this is why it's so important, rational numbers are closed with every single operation, with addition, with subtraction, with multiplication, and division. It's closed within all these sets. Okay? So that is something that you guys will need to know for whenever you're doing the homework for this. Example for some other stuff. Let's look at this. This could be an example of closure as well. We have a ratio. Both of those are integers. It is a ratio of 2 integers. It's rational. This is also a rational number. 1/2, 3/4, these are rational. Is this equal to a rational number? Well, based off of what I just said, yes, it would be. However, let me show you. Let me show you how it would be a rational number. Let's take 1/2 plus it to 3/4. In order for us to have the addition of fractions, they must have the same denominator. So let's multiply the first fraction by 2/2. Remember the LCD, we want to find this lowest common denominator. So this would be 2/4 plus 3/4, which gives us 5/4. That's still a ratio, a fraction of 2 integers. So is that rational? Yeah, this would be a rational number. Okay, so in part B of this, is the sum of any 2 rational numbers, or is the sum of 2 rational numbers always equal to another rational number? Yeah, that's what it means to be closed under addition. If you are taking the addition of any rational number and adding it together, then it is always going to end up to be a rational number. Okay, so that is always true for the reason I just said. Taking any 2 rational numbers, adding them together, is always going to end up to be a rational number. That's one of the cool things about the property. I could go into more of a detail on why that is, but I don't want to take more time than I have to. Okay? Main thing is, I want you guys to be able to say, rational numbers are closed under addition, they are closed under multiplication, they are closed under division, they are closed under subtraction. You need to be able to say that, and you need to know a little bit of why that is. And you need to be able to show a few examples of why that is. So like this 1/2, 3/4, that's a perfect example of where it would be closed, showing that it does end up in the same set. It is a rational number. Okay? Let's answer these questions. 9, is 9 a rational number? It is, because technically we can write that as 9/1. Pi is not a rational number. So what's being asked in this question is basically, is a rational number plus a not rational number, a number that cannot be written as a fraction, is that going to end up to be a rational number? Well, 9 plus pi. 9 plus pi. We know pi is about like 3.14, and this goes on forever. It does not repeat. It does not end. So if we did 9 plus that, then that would end up to be 12.14 going on forever. Is that rational? No, because the decimal goes on forever and does not repeat in any way. So this would not be a rational number. Okay? So the question is, part B, is the sum of a rational number and an irrational number always equal to an irrational number? Right? We just did an example of a rational and an irrational. Is this always going to end up to be an irrational number? That is our question. And the answer to this, if we try to take a rational number, a ratio of two integers, and add it to an irrational number, it's going to follow the same pattern. Okay? So is it always irrational? Yes, it will. Okay? If you can find one example where it doesn't, then that would be a way of showing that it is not, that it would not be irrational. We just had to find one example. But a rational and an irrational is always irrational. Okay, and on the website, there are links to some IXL problems that you guys, it would be very beneficial if you went through and practiced some of those to get in the hang of being able to say, yes, this is rational. No, this is not rational. And that would be very, very helpful. Basically, IXL is going to be able to ask you a question like 9 plus pi. Is that rational? Is that irrational? And then you choose, is it irrational or irrational? And if you know that one's rational, one's irrational being added together, you know automatically it's not rational. If you have two rationals added together, it is rational. This one, answer the following questions. Square root of 7. Is that a rational number or an irrational number? That is irrational. Square root of 28. Is that rational or irrational? That is also irrational. Okay? So this is asking, if we take two irrational numbers and add them together, what are we going to end up with? That is what we are trying to find out with this question. Okay? So we have square root of 7 plus square root of 28. Let's square root of 28. 28 has 4 times 7 that can go into it. So this would be square root of 7 plus square root of 4 times 7. We're just going to simplify this down a little bit. I want to see if we can combine like terms, put things together. So this would end up to be square root of 7 plus, okay, square root of 4 is 2, so that goes outside, and 7 stays inside. Okay? So 28 is 4 times 7. Square root of 4 gives us 2. The 7 stays inside because there's not another 7. We have one of those plus 2 more, so that's 3 square root of 7. Right? 3 times the square root of 7. If it has a square root, it is irrational as long as that square root is not a perfect square. Okay? So this right here, is this rational? No. By the way, you can also go with this a little bit in a different way. 3 square root of 7, that's technically 3 times square root of 7. So we are also kind of answering, is a rational times a irrational rational? We're kind of answering that question at the same time. So that is something you want to look at as well. Part B, is the sum of two irrational numbers always equal to an irrational? That is what we want to know with this one. Well, we just saw that it is irrational with this case. However, there is a case where the sum is not an irrational number. Okay, let me show you where. Let's say we have 2 pi, right? 2 pi. And we are adding something. Okay, 2 pi is an irrational number. It's not rational, right? 2 in front of the pi, that's an irrational number. If pi is included, it's irrational. Is negative 2 pi also irrational? Yeah, it is. Let's add those together. Isn't that 0? Is 0 irrational? No. 0 is a whole number, it's an integer, and it's also rational. So this right here would show us that not all the time. Whenever you add two irrational numbers, it is sometimes irrational and sometimes rational. Okay? So let me just recap what we just did. Adding two rational numbers together always gives you rational. A rational plus a rational is a rational. Adding a rational and an irrational number is always irrational. Okay? And adding two irrational numbers is sometimes rational, sometimes irrational. Okay? That is kind of the theme of what we are talking about with this. You need to be able to know rational, rational, rational. Rational, irrational, irrational. Irrational, irrational, sometimes. It depends on what you have. Okay? And you're going to notice as we do a little bit more that theme is going to continue on a little bit. Okay? Let's do this one. Now we're going to, instead of adding, let's do some division. Okay? I'm just going to do this one. This will be our last one that we do for today. Let's do a little bit of division. We have a rational divided by a rational. So let's go ahead and divide that. 1 over 2 divided by another fraction. Keep, change, flip. So we multiply by 4 over 3. So in other words, this would be 2/3. That is rational. So is it rational? Yeah, that works. Is it always going to be rational if you have two rational numbers divided by each other? Well, let's take this for example. 1 over 2 is rational, right? Let's divide this by 0. Is that rational? If you divide by 0? That is undefined. However, no, I'm not going to put a however in there. So this is going to be undefined. So is it always a rational number? No. We could have it undefined. However, this would not be able to be an irrational. So it's either a rational number or it's undefined. Does that make sense? Okay, so if you take a quotient, a division of two rational numbers, it will either always be rational or be undefined if you try to divide by 0. So as long as we don't divide by 0, it's always rational. Okay? So always rational except division by 0. Let me write that down. Always rational except when divide 0. Okay? And like I promised, we will pause it there. I did have some other questions of a rational divided by an irrational and a irrational divided by an irrational and what those would end up to be. Just to save us a little bit of time with that, a irrational divided by irrational, it depends. Okay? Just like with the addition, it depended on what numbers we had. The same is true with division. And also, if we take a rational divided by an irrational, that would always be an irrational number. Or if we take an irrational divided by a rational, that would be also irrational. So it follows the same pattern as the addition. So if you understood the addition, you can do the division. Okay? So we are going to end right there.